Hello again, it's Mr. Mueller here to talk about how we can factor a trinomial in this particular form if the value in front of x does not equal 1. Okay. Last week we took a look at factoring trinomials that were in this form, something like x squared plus 4x plus 4. If we have a trinomial in this form, we can simply look for factors of the constant that add up to the coefficient in front of x with the b value. Now, when we approach this particular polynomial and we're told to factor it, the process is much more complicated because that value in front of x squared is not equal to 1. So I'm going to show you what I personally believe is the easiest way to do this. It eliminates a lot of the guessing, and it kind of gives us a set process to follow for these particular polynomials. So in order to factor something like this, we are going to first multiply the a value in front of x squared times our constant. So 20 times 3 is going to give us 60. We are now going to look for factors of 60 that will add up to b, or the value in front of the x. So we're looking for values or factors of 60 that will add up to 17. So the factors of 60 that add up to 17 are going to be 12 and 5. A positive 12 times a positive 5 gives us 60, and a positive 12 plus 5 gives us 17. So they need to add together to get that, and they need to multiply to get 60. So now that we have these particular values, we are going to do a little bit of replacing. We're going to replace 17x in this equation with a 12x and a 5x as follows. So the 20x squared will stay. But rather than write 17x, I'm going to add 12x and 5x, and the 3 is unchanged. So, as you can see, we replaced 17x from the original equation with 12x plus 5x. Using what we know about combining like terms, 12x plus 5x is indeed 17x. So the original equation I highlighted in yellow, and this particular equation I'm working with right here are indeed the exact same equation. This now allows us to factor by grouping. I'll group the first two terms, I'll group the second two terms, and take a look at what I have. The first two terms here have a 5 and an x in common. Nope, excuse me, that's incorrect. They have a 4 and an x in common. So I will factor out a 4x, and I'll multiply that by 5x plus 3, as we learned in section 9.8. The second two back here don't really have anything in common other than 1, so we'll just factor out that positive 1, and we'll multiply by a 5x plus 3, which is unchanged. It's not a coincidence here that these two particular factors match. Because they match, and because we're factoring by grouping, we know that we can then factor out that particular factor they have in common, the 5x plus 3, and we can multiply it by what I like to say, what's left over, 4x and a positive 1. So this particular product of these two binomials is a correct factoring of 20x squared plus 17x plus 3. Now, it's important to remember that we can always check this. Once we get our answer, if you have extra time on a test or a quiz, it's beneficial to go back, make sure that your work is correct. So let's check this. 5x times 4x is 20x squared. 5x times 1 is a positive 5x. 3 times 4x is a positive 12x. And 3 times 1 is a positive 3. Combining like terms leads us to the polynomial 20x squared plus 17x plus 3. So we know that our answer is correct, and we are done with this particular problem.